So hello to my fellow future engineers. So this is the requirement for the comprehensive examination in design and construction. So my name is Cristel Lyka Abalos, and I will be discussing the lesson number 2, which is the column section or the column design. So let me read the problem number 1. So design a square tiled column is to support an axial dead load of 575 kN and an axial live load of 770 kN. So assume FC is equal to 27.6 MPa and Fy is equal to 414 MPa and use 28 millimeter main bars and 10 mm ties. So before we proceed to our solution, let us determine first the given value. So the axial load is 575 kN. The axial dead load is 770 kN. And let's assume the FC or the compressive strength of the concrete is equal to 27.6 MPa and the Fy is 400 MPa, which is yung yield strength. So let's proceed to the solution of this problem. So we have the formula of AST is equal to 0.02 Ag. So first, let us assume muna yung value ng AST, which is the steel ratio. So since meron tayong ideal assuming between the 0.015 or 0.015 Ag to 0.03 Ag, so for this problem, gagamitin natin is 0.02 Ag. So we have this formula, Pu is equal to 1.2 times dead load plus 1.6 times live load. So this is the formula to compute the load combination. So, substitute lang natin yung value ng dead load and live load to the given formula para makuha natin yung mismong axial load or yung axial combination load. Computation for Pu is equal to 1.2 times the 575, which is the dead load, plus 1.6 times the live load, which is 770 kN. So we get the value of Pu is equal to 1,992 kilonewton. Then, pag nakuha na natin yung value na axial load, proceed na tayo sa pagkuha ng ating Ag or yung gross area. So, based on the formula given on the NSCP 2015, we have this the resistance factor times 0.80 multiplied to 0.85 times the compressive strength, which is the FC, times the Ag minus AST plus the yield strength times the AST, or the area of the steel ratio. So, through that formula, substitute natin yung mga given value to compute the gross area. So, we have 1,922,000 is equal to 0.65 times 0.80 times 0.85 times 27.6 multiplied to Ag minus 0.02 Ag, which is yung nakuha natin kanina na value ng AST, plus 414 times 0.02 Ag. So, kinonvert lang natin si 1922 kilonewton into newton. Kaya naging 1,922,000 newton. And the value of the resistance factor based on the NSCP 2015 is 0.65 based on the given formula. So we get the value of the gross area. So Ag is equal to 118,198 millimeters squared. So since squared tiled column ang i-design natin, we will be having the formula of b squared is equal to ag. So b squared is equal to 118,198 square millimeter. So para sa dimension ng ating column, square root of b squared, so square root of b squared is equal to 343.8 millimeter and approximately 345 millimeter. So let's substitute yung nakuha nating value to this formula, which is the AST is equal to 0.02 Ag. So we have 0.02 times 345, which is the column size we get before. So 0.02 times 345 squared. So we have the value of AST is equal to 2,381 square millimeter. So let's continue to compute the number of bars. We have the formula of number of bars is equal to AST all over AB, which is AB is equal to pi over 4 times B squared. So yun yung area ng ating circle. So M is equal to 2,381 all over pi over 4 times 28 squared. So we get the number of bars is equal to 3.87 and approximately 4 bars na siya. So wala kasing 3.87 na number of bars. So assume natin na 4 bars na siya. So therefore, we will use 345 millimeter by 345 millimeter column with 4 pieces of 28 millimeter main bars. So lastly, the maximum spacing of ties. So tie spacing shall not exceed 16 diameter of longitudinal bars. So for letter A, 16 times the diameter of bars, which is 28, is equal to 448 millimeter. So for the tie spacing shall not exceed 48 diameters of tie bars. So for the letter B, 48 times tie diameter, which is the 10 millimeter, is equal to 480 millimeter. So least dimension of column is equal to 345 millimeter. So that concludes our problem number 1. So let me read the problem number 2. So calculate the ultimate axial load capacity of the composite column shown. So assume FC, or the compressive strength of the concrete, is equal to 21 MPa and Fy is equal to 250 MPa for the W section. So let's use NSCP 2015. So the relevant properties of wide plunge steel W12 by 211. So the weight is 315 kg per meter. So the area is 40,000 millimeters squared. So the depth or the height is 399 millimeter. So the Ix, or the moment of inertia along x-axis, is equal to 1,107 times 10 raised to 6 millimeter to the fourth. So the Iy, or the moment of inertia along y-axis, is equal to 429 by 10 raised to 6 millimeter to the fourth. So first, compute muna natin yung area ng concrete. So we have the area of concrete is equal to Ag minus the ASS. So based on the figure, ang total area is 480 by 480. And since the area of the steel is given, so which is 40,000, we will get the area of the concrete right away. So AC is equal to 480 squared minus the 40,000 millimeter. So we will get the area of concrete 190,400 millimeter squared. So using NSCP 2015, calculate the ultimate axial load capacity, which is the resistance factor times 0.80 multiplied to 0.85 times the compressive strength times the area of concrete plus the yield strength times the area of the steel. So through this formula, let's substitute the given and computed value na kanina. So the resistance factor is 0.65 multiplied to 0.80 times the 0.85 times 21, which is the compressive strength, times 190,400 plus 250 times 40,000. So we will be having the ultimate axial load capacity of 6,967.3 kilonewton. So that concludes the problem number